we look at the net change theorem. And here's what the net change theorem says. It says that the integral of the rate of change is the net change. The integral of the rate of change is the net change. Kind of, yeah. So as you look at this, I have f prime of x. What this is stating is that whatever you're taking the integral of is a rate of change function. Who can tell us, what do we see in our everyday lives? That's the rate of change function. Okay, slope. Where do we see this on a daily basis? Think of outside mathematics class. What is something you do that involves rate of change? Drive. We drive a car, miles per hour, right? So think about this. If we have a velocity function, so a rate of change function, and you take the antiderivative, what is the antiderivative of velocity? Position. So the idea is this. If you take the antiderivative of velocity, it'll tell you where you are from where you began. Kind of like how many miles you've traveled to some degree. Snow accumulation, okay, falls at a certain rate over a given period of time. Take the antiderivative of that rate function, it will tell you how much snow actually accumulated. You look at debt. If we have a function that shows us at what rate we're accumulating debt, when you take the integral of it, it will actually tell you the actual dollar amount that we've accumulated. So these accumulation functions are very important. So this is what the net change theorem says. Now there's two parts of the net change theorem that we have to look at. Number one is net change, or the displacement of the particle, and then B, total distance. So I like to think of these in terms of velocity problems, and I'll start by doing this. Let's bring us back to where we started first semester. If I'm standing here and I walk forward and I walk back, what is my displacement? 0. However, I have a total distance traveled, correct? So the net change theorem truly refers to, in this situation, displacement. It takes into account that you may have some that's positive, you may have some that's negative, okay? It could be, oh, okay, I'm sorry. We will work something out to find what distance is, but you're absolutely right. So when I walked from this spot and returned, my displacement was 0, but I did have a total distance traveled. So this in itself will not give you the total distance, but I'll show you how to figure that out very quickly. Okay? So particle moves at a velocity modeled by this function where t is measured in seconds and v is measured in meters per second. Let's start by examining this function. What shape does that make? Parabola, and it's t minus 3 times t plus 2, so I can sketch a pretty quick graph of this. Looks like it has x-intercepts at negative 2 and positive 3, and the parabola goes up, so that's my function. And we're going to look at it over the interval of 1 to 4. Okay? So this is a velocity function. A velocity function. When I take the antiderivative, or the integral of the velocity function, I will come up with displacement. And that is represented by that shaded region. You tell me, what do you notice about that shaded region? Both positive and negative. By looking at what we have up there, do you think that we will end up traveling more units to the right or more units to the left? More units to the left, because you see a larger area underneath the x-axis as opposed to above the x-axis. So the way we figure out our displacement, very important, is we simply set up the integral from 1 to 4 of the velocity function That's all we do. That's the integral 1 to 4 of t squared minus t minus 6 dt. And the antiderivative of t squared is t to the third over 3. That's t squared over 2 minus 6t. We're going to evaluate that. 4 and at 1. Plug in 4, you get 64 over 3. 4 squared divided by 2. 8. 6 times 4. 4. But that amount minus, now I plug in 1. 1/3 minus 1/2 minus 6. On the AP exam, if you're not given a calculator here, here's how I try to write it. 64 over 3 minus 8 minus 24 minus 1/3 plus 1/2 plus 6. And I just try to combine terms that work out nicely with one another. So for example, 64 over 3 and negative 1/3. 63 thirds, which is 21, right? 63 divided by 3, 21. Minus 32 plus 6 plus 1/2. That's where we'll pick up when we get back. We'll evaluate that, and we'll do the rest. More flavor to it. Okay, here we go. So I've got 21 minus 32 plus 6 plus 1/2. And so I've got, let's see, 21 negative 32 make negative 11 plus 6 is negative 5 plus 1/2 is negative 4.5 or negative 9 over 2. Now, does it seem reasonable that negative 9 over 2 would be an answer? But what should be my label? What is the units? Nope. Meters. Because we are looking for the displacement. Okay? All right. So now we got to do B. No. We got to do B. B says find the total distance. What's different about that question? Okay, displacement. Okay, but total distance, it would take this and add it to the absolute value of that, correct? Take out your calculator. We're going to type in here x squared minus x minus 6, which is my velocity function. But I'm going to insert something around it. I'm going to insert an absolute value sign. In second catalog, you got absolute value. See that? So if you look at this graph, it takes the graph that I have, but it takes this inner portion here, and it brings it right above the x-axis, like so. See how it does that? So if we want to calculate part B, the way we do so is we calculate the absolute value. So it's the integral from 1 to 4 of the absolute value of t squared minus t minus 6 dt. On the AP exam, you're going to be able to do this by simply using your calculator. You're going second calculate number 7. Lower limit of 1, upper limit of 4. And you can see I get 10.167. What's my label? Meters. Yep, so the lower limit you do 1, the upper limit you do 4. Yes. However, it's very possible they won't give you your calculator. That's kind of frustrating, isn't it? So I'll show you. This is what we have to talk about, okay? Because this is part of the AP exam as well. And I do want you to do this on your assignment today, and this is kind of the bigger part. The other stuff we do is easier. This is the harder part. Total distance is going to be the absolute value. I have to find this amount as well. Anybody got an idea of how I'll do that? Okay, you could do that, exactly. You could write a new function. Or what I could do is I could find the area from 4 to 3. That would be positive. And I could find the area from 1 to 3. That would be negative, and I could just make it positive and add the two together, correct? So in order to do this, I'm going to add those two integrals together. So you set up two integrals. The integral from 3 to 4 of t squared minus t minus 6 dt. And we know that that will be positive area, right? Now add that to the integral from 1 to 3 of t squared minus t minus 6 dt. And we know that that will be negative area. So what we'll do is we'll take the positive and we'll add it to the absolute value of this one. All I did is broke it up into two pieces, 1 to 2, 1 to 3, and 3 to 4. Okay? Yes, exactly. To check your answer, but you do need to set it up into the two integrals because you will be asked on the AP exam. They actually want you many times to actually write this piece out. There'll be times they want you to write that out and then express it as well using your calculator. So we have to be used to it. I have two questions like this for you. So, yep. So, this is going to be negative. So what we're going to do is we're going to actually take the absolute value of that. Whatever we get as a result, we'll take the absolute value. Yeah, you could do that as well since you know it. Yep, exactly. So we are going to cheat and use our calculator a little bit because otherwise I'm afraid we're going to run out of time. We'll do t to the third over 3 minus t squared over 2 minus 6t, and we'll evaluate that at 4 and 3. Yep, so I'm doing this right now. On your test, you can use your calculator, but I will ask you to write the two integrals. You can't just do the second calculate option. I want you to break it up into two integrals. So you understand that one's positive and one's negative. Plus the absolute value of, and this would be t to the third over 3 minus t squared over 2 minus 6 evaluated at 1 and 3. So here's how I'm going to create a shortcut here. I'm going to type this into my calculator and then go to my table to evaluate those. 6t. So I'm going to go into my calculator. I'm going to do value. Again, I'm just doing that to try to save time here. I'm afraid we're going to run out. So we'll go x to the third. Divided by 3 minus x squared divided by 2 minus 6x. And table set will go into ask. And in my table, I'm going to generate values of 4 and at 3. So negative 10.67 minus negative 13.5 negative 13.5. And then over here, I'll evaluate at 3, which we said was negative 13.5. And then if you plug in 1, you get negative 6.16. So let's figure these out. Negative 10.67 do plus 13.5, and I get 2.83. We knew that that was going to be positive, right? Plus the absolute value of, we got negative 13.5 plus 6.167. And we knew that that was going to be negative. So if we simply add those two together, you can see that we come up with 10.167. That's an estimation. The actual fractional value is 61 over 10. We had a little bit more time during the second hour due to not having our lunch break in there, and so this is what we came up with. So, okay, question. All right, you have fun. All right, let's flip over to this side. Okay, these two are easier. Oh yeah, units. What's the unit? Thank you. Meters. Well, in this problem, it says, whoop, wrong class, never mind. Okay, so in this problem, it says that you're in meters per second. So therefore, that's our measurement. So this is meters. Okay, all right, we flip it over. All right, now instead of a function, it gives us as a table. So it says snow is accumulating at a rate of R of t. Let R of t be measured in inches per hour. How are you doing, bud? Good. So R of t is equal to this, and t is equal to that. Tell me, what does 3 represent for t right here? What does this 3 represent right here? 3 hours. Very good. Let's go to R of t. What does this 3 represent? 3 inches per hour. So at time 4, the snow is falling at a rate of 3 inches per hour. Yep, R of t. What does 60 mean? It's not snowing. Doesn't mean that there's 0 inches on the ground. It means that it's not accumulating anymore. See that? It says give upper and lower estimates for the accumulation of snow after 6 hours. You tell me, what's the greatest rate at which the snow is falling? 3 inches per hour. So what is the most amount of snow that you would expect to have? 18 inches. 3 inches per hour times 6 hours is 18 inches. That's an upper bound. That's the largest amount it could be. It's an upper estimate. Okay? Top numbers are the hours for time, and then this is our rate. What's the lowest estimate? 0 inches per hour times 6 hours is 0 inches. Your lower bound. T is the time that's elapsed because it's been snowing. R of t is the rate at which the snow is accumulated. So 2 inches per hour, 1 inch per hour, half inch per hour. It starts up snowing pretty heavily, doesn't it? But then it tapers off, and then at time 4 and 5 hours, it speeds up again. The fact is, you guys, we don't know what this function looks like. It might look something like this. But if we bound this from 0 to 6, here's what we're doing. We're saying that the greatest rate is 3. And if we were to draw a rectangle at that spot, that would be the accumulation of snow. That's too much, right? Okay? So we know it's less than that. Okay? All right. B says, let's actually try to find approximately how much snow fell. So it says find M6. What does M6 mean? Midpoint sum. Okay, so if you look here, I have 1 interval, 2 intervals, 3, 4, 5, 6. What's the width of each interval? 1 times, what's the midpoint between 0 and 1? 1/2. Do you know the rate at 1/2? Could I estimate it? What would you estimate it? 1.5 plus 0.75 plus 0.75 plus 2 plus 2.5 plus 1. How many heights should I have? 6, and I have 6 here. So 1 times 1.5, so that's also 1.5, so that'll be 3, 4, 5, 6, 8.5. Does that seem like a reasonable estimate? Yeah, it does. So 8.5 inches of snow accumulation. Yes. Yep. So we're integrating the rate function to give us the total amount. Last example, a car travels at a velocity modeled by this. It should be v of t is equal to 1 plus 4t minus t squared. That's what it should be. Where velocity is measured in miles per hour. At 4 hours, the car is located at mile marker 64. So we got a car traveling at 4 hours. It's at mile marker 64. The question is, at 1 hour, what mile marker is it at? Well, if I knew the displacement of the car, then I could figure out where it started, right? Suppose that the car was displaced 50 miles. Then where would it be at time 1? 14. Suppose the car was displaced 24 miles. Where would it be at time 1? 40. So I need to figure out the displacement of the car. Over the period from 1 to 4. Antiderivative of 1. See? Plus. Yep. Yep. Antiderivative of 4t. T to the third over 3. Evaluated 4 and 1. 4 plus, what is 2 times 4 squared? Whoop, it's a minus there, isn't it? Sorry about that. Okay. Yeah, sorry about that. Okay. And then minus 64 over 3. Now I plug in 1. And I get 1 plus 2 minus the third. What's negative 64 thirds plus 1 third? Negative 63 over 3, which is negative 21. 4 plus 32 is 36. Minus 1 minus 2 is 33. So that means that the displacement is 12 miles. So that means from where the car started, where the car ended, is a total distance of 12. So where did it start? What mile marker? 52. So it didn't travel very far, did it? Must be in Los Angeles. Do I know that it only traveled 12 miles? Its total distance traveled. It could have gone like this, couldn't it? Gone like that. Okay. The fact is that could have gone back and forth a lot, picking up a bunch of people. Could have been a taxi. But the fact is, we know that it's total displacement there. It started at mile marker 52. Fair enough? Okay. All right. So, good job. A few of these problems were new for me this year. I didn't teach them last year. Hopefully, this works out. We'll see how they kind of fit in with the AP stuff that we're doing as well. Here's your assignment. I warned you that you would have some decent amount of homework coming this week. Monday will be no different. You get a pretty heavy assignment on Monday. Or Tuesday. I can't remember which one it is, but early in the week next week, you get a pretty heavy assignment. We will have a work day in class. I'll be ready for a test either next week, Friday, or the following week, Monday or Tuesday. Right around that time frame is we're going to try to look to get a test. So you'll for sure have a test before spring break. For sure have a test before spring break. Everybody good? Have a great weekend, you guys. Get some work done. Get some rest.